Good day, IGCSE students. Today we are going to solve past paper May-June 2021, paper 42, number 9. So here, because this one is in a factored form, we will factor this one. So we have y, or the common monomial factor as our common monomial factor. Then x cubed divided by x is x squared here, minus, and we have 4 over 1 is still 4. X squared divided by x is x, and then plus 4 again, and x divided by x is 1. So we have this trinomial. Now, what do you observe about this trinomial? This is a perfect square trinomial because we can take the square root of 4, which is 2. And this is also perfect square, which is x times x squared. So, let us factor this one. We have x here, and then we have x times x squared. This is minus, therefore this is also minus, and the square root of 4 is 2. Actually, we have x minus 2 times another x minus 2. But we have x minus 2 and x minus 2. We are exponent 1 and 1, so we have to the second power. So our ai is equal to 2 here. Don't include a sign because that one is negative, that one is negative. We'll just get this number, which is positive 2. Question II. On the axis there, sketch the graph of our function, indicating the values where the graph meets the axis. So here, let us review some sketching of polynomials. Okay. So here, if you have y, is squared, let's have the end behavior of the curve. So when we have x squared or even exponent, we have x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, and this one is positive. The end behavior of the curve is one is here and the other one is here, and they are symmetrical on the y-axis. That is for positive x squared. What about if we have negative? So if we have negative here and we have x squared, I'll put here even, exponent, there's also even, but when it is negative, it will be just on the other side. So it will be here, going down, and on the other side, it is going down. Okay, they are also symmetrical to this y-axis. What if our y is cubed or an odd exponent? So what will happen to the graph? The end behavior of the graph. If this one is 3, 5, 7, then our graph, we have the end behavior of the graph on the right side here is that going up there, and the other one is in the 3rd quadrant, which is going down. Okay, if that is positive. If this one is negative, then the left one will go up here, and the end point here, or the end behavior here, is on the 4th quadrant, will go down. This one's for negative, this one is for positive. Okay. Now, what about values? the values, we will set this one. We will use this one and not this one anymore, because we are going to find the values of x here and the value of x here. Okay, so let us find the values where our graph will intersect. Y is equal to this one, x, and then x minus 2 to the second. We use the zero factor property. We equate this one to 0 because this one will become 0, and then we solve for it. So x is equal to 0 because we set y to 0. So one value is 0. It will pass through the origin here, or pass or bounce or slide. We don't know. And this one, x minus 2 is equal to 0. Anyway, they are both the same, x minus 2, and the other one is x minus 2. So they are the same, so there will be only one value. So here we have x minus 2 is equal to 0, and x here is equal to positive 2. So our curve will pass or intersect or bounce or slide at point 0 and 2. So where is that in our graph? So our curve will pass, bounce, or slide here and on the 2 here. So on the 2 here. Order, what's the order of this one? This one is cube, 3. So that one, where is the cube, exponent, this one, and this one is positive. Therefore, if that one is positive, what is the behavior of the endpoints? So it will be this one. 1 is here. Do not put here because we have the last point here, which is 2. So 1 point is here, something like that. And the other one is after the 0, which is, so these two are the endpoints of our graph. Now, let's have the multiplicity. So this x here on the 0 here, because this one is 1, it means it will pass the multiplicity. For example, we have 1, the multiplicity or exponent is 1. The curve will just pass. If it is on the above, it will just pass through the x-axis and go to the lower part. If that is 2 here, for 2, it will bounce, meaning it will not pass, it will just bounce like a parabola. So it will bounce. If the multiplicity is 3, it will slide. Okay, it will slide. So, like for example, this one, y cubed. What is the multiplicity? It's 3. 3. If that is 3, it will slide. So it will pass and slide like here, and it will slide here. So it will be like that one, slide. If that is x squared, then here, and it will bounce. So this one will be a parabola. So it will pass here on the 0 because that one x is equal to 0. That one. So it will pass here. Okay. What about on the positive 2? Positive 2, this one is 2. Meaning it will bounce. So here, because this one is the curve, it will bounce here. It will bounce, it will not pass. So it will not pass, but it will pass here, directly here, and this will be a straight line. And this is our curve. And that is how to sketch a polynomial or any curve. Okay, letter B. Find the equation of the tangent to the graph at x is equal to 4. So, if we are going to illustrate that one, we have our sketch of the graph, this one. And then, we have the tangent, a line, which is tangent at 4. X equals to 4, there. So, we will find the equation of this tangent. Our answer must be in the form y equals mx plus c. First, we will find the m. And what is m? Is slope. How do you find the slope in this equation? Derived function, or we are going to differentiate this one, and then we substitute the value of x in our derived function, and then that is the slope. We just simply use y prime. This y prime, or the dy over dx, is the slope. So let us differentiate this one. 3 times the 1 here is 3. And then what do you do with exponent? We subtract 1 here. 3 minus 1 is 2. Minus here. 2 times 4 is 8. And then x, subtract 1 from 2, it's 1. Okay. Plus here, 1 times 4 is 4. X is 1 minus 1 is 0. X to the 0 is equal to 1. So we don't have the x here anymore. So this one is the derived function of our function here. So that is a dy dx, and this one is the formula or equation for the slope. Now we will substitute x is equal to 4 here. So our slope is equal to 3. The x now is 4. So we have 4 squared minus 8 times the 4 plus 4. Our slope, which is also the y prime, is equal to 3. 4 times 4 is 16, minus 8 times 4, 32, plus 4. And then we multiply this one. Slope is 48, and then minus 32 plus 4 here. And our slope is 20. So the slope of the tangent is 20. Now we have the m. We have y minus y sub 1 is equal to m times x minus x sub 1. This is point slope form. We have a point, x sub 1, y sub 1, and we have the slope. So we have already this one, the x sub 1, which is 4, that one. But we don't have the y coordinate of this x sub 1, which is the y sub 1. So we need to find this one. So what do? We substitute x is equal to 4 now to the original equation. So we know the coordinate of the y if that one is at 4. So let's have the original here. I'm going to put a line here. So we'll have y here. This one is 4 raised to the 3rd power minus 4. X is 4 squared plus 4 times 4. Okay. So our y, the coordinate y sub 1, actually this one is y sub 1, is equal to 4 times 4, 16 times 4 is 64, minus 4, 4 times 4 is 16 here, plus 4 times 4 is 16. Y, or y sub 1, is 64 minus 4 times 16 is 64 plus 16. And then y sub 1 now is equal to 64 minus 64 is 0 plus 16. Therefore, our y sub 1 or y coordinate of our x is equal to 4 is 16. Now we have x sub 1, we have y sub 1, we have the slope, which is 20. You can now put everything here and find the equation of the tangent. So let's have here y is still y, put y here. We replace y sub 1, and y sub 1 is 16. Okay, 16 is equal to our m here is 20 times x minus x sub 1 is 4. So this one is 4. And then y minus 16 is equal to 20 times x is 20x. Positive times negative is negative. 20 times 4 is 80. Then transpose 16 to the other side here. So we have y is equal to 20x minus 80 and then plus 16. So y now is equal to 20x and then minus, so this one is 4, 10, 4, 7, 1 is 1, so this one is 64. And this is the equation of our tangent at x equals to 4.